Hi everyone, this video series is all about SAT math hacks where we discuss smart tricks and strategies to solve SAT math problems. This video is on SAT math hack number 2, try out the options. Let us see what that means. So look at this first question which says, for what value of x is this equation satisfied? For what value of x is this equal to 10? And the traditional way would be to solve this equation and find the solution and then pick the correct answer from the options. But what you can do instead, and in a way solve this faster, is you can try out all the options one by substituting them into this equation and seeing which one satisfies the equation. So let's take minus 5, x equal to minus 5. So if I substitute x equal to minus 5 into this equation, on the left side what do I get? So 2 times minus 5 plus 5 and the absolute value of that plus 3. So 2 times minus 5 is minus 10 plus 5 is minus 5 and the absolute value of that is 5. So you get 5 here and then a plus 3 which will be 8, but that is not equal to 10. So minus 5 does not work. Now let us substitute x as 4. So 2 times 4, so let me write that here, 2 times 4 plus 5, the absolute value of that plus 3. So 2 times 4 is 8, 8 plus 5 is 13, absolute value of 13 is 13, but that plus 3 is 16. So that also does not work because we need this thing to be equal to 10. Now if I substitute x equal to minus 6, so I get 2 times minus 6 plus 5, the absolute value of that plus 3. Now 2 times minus 6 is minus 12 plus 5 is minus 7, absolute value is 7 and 7 plus 3 is equal to 10. Great. So this option x equal to minus 6, this works for us. So this is our answer in this case, and you can actually check that the fourth option also does not work. So this is what it means to try out the options. You take the options one by one and you use them in the given question and you see which one is fitting. Now let us take question number 2. Which of the following is a solution to this equation here? And once again, the traditional approach would be to solve this equation and find out which values of x are satisfying this. But in this case, once again, you can simply substitute the given values to see if anyone is satisfying the equation or not. So if I take x equal to 0 into this, if I plug it into this equation on both sides, so I will get 7 times 0, that is 0, plus 16. So root of 16 plus 9 on the left side, and I will get 0 plus 7 or 7 on the right side. Now root of 16 is 4, 4 plus 9 is 13, but 13 is not equal to 7. So this does not work. Now if I take x equal to minus 1, so 7 times minus 1 plus 16, the square root of that on the left side, plus I have a 9 as well, and then on the right side I have a minus 1 plus 7. So let us see what I get here. So on the left side, this 7 into minus 1 is minus 7 plus 16 is 9, root of 9 is 3. So this whole thing here is 3, 3 plus 9 is 12 on the left side, but minus 1 plus 7 is 6 on the right side. So this also does not work. Now let us try 12. So if I put 12 on the left side, I get 7 times 12 plus 16, the square root of this, plus 9 on the left side, and on the right side I will get 12 plus 7. Okay. Now on the left side I have 7 times 12 is 84, 84 plus 16 is 100, the square root of that is 10. So this whole thing here is 10. So 10 plus 9, and on the right side I have 12 plus 7, which is 19, the left side is also 19. So actually x equal to 12 will work for this equation. So our answer here is 12. 12 is the solution to the equation. So you can see how quickly the question can be solved if you just take the options and try them out one by one. So that is what it means to try out the options. Here's our question number 3. We have a system of linear equations and we are told that this system of equations is satisfied, or we are asked it's satisfied by which of the following ordered pairs x comma y. Once again, you could do the traditional approach of solving this pair of linear equations and seeing which one is correct, but I'll go the other way around. I'll try out the options and see which one works. So I'll take 10 and 1 first. So if I substitute 10 and 1 here, so I get, so I'm doing 10 and 1 first. So in the first equation, I get 2 times 10, that's 20, minus 7 times 1, so that's 7 is 13, so this is good. But in the second equation, I have x, which is 10, minus 3y, so 3y will be minus 3, which is, it should be equal to 5, but that's not really the case. So 10 and 1 does not work. Now let me take minus 1 and minus 2. So 2x minus 7y, so 2x will be minus 2, minus 7y will be plus 14, and we need this to be equal to 13, but that's not correct. So I can directly rule out this option here. Now I'll take minus 4 and minus 3 and see if this works. So 2x minus 7y, so 2x is minus 8, minus 7y will be plus 21. This is equal to 13, yes it is, so this works. But I'll now take the second equation, x minus 3y equal to 5. So x is minus 4, minus 3y will be 9, minus 3 times minus 3, and this should be equal to 5, and yes indeed it is. So this point minus 4 minus 3, or this pair of values x comma y, is satisfying both my equations. So actually minus 4 comma minus 3 is our answer in this case. So you can see that by trying out the options, you did not need to solve this pair, you just could try the options and figure out which one is the correct answer. All right. Question number 4, very similar. You have a system of equations and you are asked which ordered pair x, y is the solution to the given system of equations. So once again, let's just quickly substitute each of them. I'll first take minus 4, 0. So if I substitute minus 4, 0 into the first equation, I'll get 0, y is 0 is equal to twice of minus 4 plus 2 is minus 2, and minus 4 minus 1 is minus 5. So clearly this is incorrect. So minus 4, 0 does not work. What about 2, 0? So 2, 0, I'll once again substitute it into the first expression, first equation. So y, which is 0, is equal to twice of x plus 2, x plus 2 will be 4 in this case, x minus 1 will be 1, and once again this is incorrect. So even the second one does not work. Let me take the third one now. So I'll take 0 comma minus 4 and y equal to, so the first equation, minus 4 equal to twice of x plus 2, which is 2, and x minus 1, which is minus 1. So now this works. Twice of 2 is 4 times minus 1 is minus 4. So this is correct. Now let's check if this is also working for the second equation. So y equal to 2x minus 4, which means minus 4 should be equal to 2x twice of 0 minus 4. And yes, this is indeed correct because I'll get minus 4 on the right side. So this equation is also satisfied. So 0 comma minus 4 is the answer, correct answer to this question. All right, so question number 5. Now this is on inequalities. X is greater than equal to 3 and minus 2x plus y is less than 11. And this is a pair of, or a system of inequalities, and we are told that the point 5 comma y is a solution to this system, and which of the following could be the value of y. Once again, we will try out the options instead of solving this. So we are already told that the point 5 comma y is a solution to this pair. So we know that x is 5, which is greater than or equal to 3. So the first inequality is already satisfied, and I'll just plug in x equal to 5 into the second inequality. So that will give me minus 2 times 5 plus y is less than 11, which means minus 10 plus y is less than 11. And now all I need to do is to check which of these options for y will satisfy this. So if I take y is 21, so minus 10 plus 21 is 11, it's not less than 11, so this one does not work. If I take y 25, so minus 10 plus 25 is 15, not less than 11, does not work. If I take y equal to 20, minus 10 plus 20 is 10, is less than 11, and therefore this works. So y equal to 20 it could be a value of y. So that's the answer in this case. Question number 6, for a linear function f of 0 is 5 and f of 3 is 11, which equation defines f? So once again, you could ignore the options and you could use this information to try and find an expression for f of x. But let's be smart, let's try out the options and see which one works. So f of 0 equal to 5 means if x is substituted as 0, the function's value should be 5. So if I substitute x equal to 0 in this case, I'll get 5. So this could be a correct answer, a potential correct answer. If I substitute x equal to 0 here, I will get 2. So this one won't work. X equal to 0 here will give me 0. This one also won't work. X equal to 0 will give me 5 here. So this one could also be a potential solution. So I have already ruled out this and this as my potential correct answers, and the choice is now between A and D. Now I'll take x as 3 and see if that gives me 11. X as 3 here gives me 6 times x, or 6 times 3, 18 plus 5, 23, which is not 11. So A does not work, but that means that only option D is correct, and you can indeed verify. If you take x as 3, so 2 into 3 is 6 plus 5 is 11, which is what we need. So f of x is 2x plus 5. So you did not need to figure out f of x on your own. You could just be guided by the options. You could try out all the options and figure out the correct answers. So you can see how powerful this technique is. Now here's to the last question. Number 7, you are given a table of values for x and f of x, and you are asked which equation defines f. So you're given 3 values, 3 value pairs for x and f of x. For x equal to minus 1, f of x is 10, 0 is 14, for 1 is 20. And using this, you're asked which equation defines f. So once again, the traditional approach would be to try and figure out what the function could be from this table, but actually we will just try out the options. So in general, x equal to 0 is the easiest option to easiest substitution to try out, because it instantly makes many of the terms in an expression equal to 0. So if I take x equal to 0 in this case, in the first expression, I'll get 0, 0, but 14, and we need 14. So this could be potentially correct. If I substitute x equal to 0 here, this also gives me 14, could also be potentially correct. X equal to 0 here also gives me 14. So that could also be potentially correct, and even this one gives me 14 for x equal to 0. So all 4 are giving me 14 at x equal to 0. So all 4 could be correct. So now let's take the next easiest substitution, which is x equal to 1. And because evaluating an expression for x equal to 1 is fairly easy, so we just start substituting x equal to 1. So if I do it here, I'll get 3 times 1, 3, plus 3 here, plus 14, which is 20. So this is still an option because I am getting f of 1 is 20. If I substitute 1 here, I'm getting 5 plus 1, 6 plus 14, 20. So this is also an option. If I substitute 1 here, so I get 9 minus 1, 8, plus 14, 22. So finally one option is ruled out, this won't work. And if I substitute x equal to 1 here, I get 1 plus 5, 6 plus 14, 20. So yes, this could also be a potential option. So now the tiebreaker is this third value of x, which is minus 1. So let's put x equal to minus 1 here. I'll get 3 times minus 1 square is 1. So 3 plus minus 3 plus 14, and that's 14. But I need a 10 here. So this one won't work. If I substitute minus 1 here, I get 5 times 1, that's 5, plus minus 1. So 5 plus minus 1 is 4, plus 14, that's 18. So this one also does not work because I need f of minus 1 to be equal to 10. So let's finally check this. It should be the correct answer. If I substitute minus 1 here, so I get 1 minus 5 plus 14. So 1 minus 5 is minus 4, plus 14 is 10, which is what we need, and therefore option D is the correct answer in this case. So try out the options is what we did here. We just used these values, substituted them into each option to figure out which was the correct one. So that's the hack. Try out the options. I hope you liked it. Let me know what you think in the comments.